Hello, this is Team 12 from Grand Valley State University, and our senior design project was to develop a Siemens PLC training cart with sponsorship from Mission Design and Automation. Mission's current training system is built around Allen-Bradley PLCs and lacks structure. With more customers moving towards Siemens systems, there's a growing need for a structured, hands-on approach to help engineers learn Siemens programming. Our solution is a mobile training cart built to simulate realistic Siemens automation environments. It includes a custom-built aluminum frame, caster wheels, and a Lexan safety enclosure. The core system features an XY servo-driven gantry and a vacuum-based end-of-arm tool, which picks and places 3D printed parts with unique barcodes. The cart is designed for easy mobility throughout Mission's facility, using 4 caster wheels and a handle. Once positioned, 2 of the wheels can be locked to keep the cart securely in place. Looking more closely at the side of the cart, you can see several key components we've mounted here. There's a storage bin for holding the QR-coded parts or any small items a user may need, and the air hookup point is also conveniently located on the side. Below the work surface, you'll find the electrical panel enclosure, which houses the majority of the system's electrical component wiring. To get the training cart up and running, it must be properly connected to both power and air. The system operates on 480 volts and compressed air, consistent with many real-world industrial environments. These connections are designed to be quick and user-friendly. The main power switch is located on the front of the electrical enclosure for easy access. Here, you'll see a demonstration of the key and sensors accurately detecting the parts in each of the nests. You'll notice that each nest changes color from green to gray when a part is no longer detected. This visual feedback allows users to easily confirm whether a part is present or missing. One of the key safety features are the light curtains. If someone reaches into the cell while motion is active, the light curtain is triggered and the system halts immediately. The second safety measure is an emergency stop button. The e-stop immediately cuts power and air to the system. A manual reset is required before operation can safely resume motion. To access the back door, users must press the Request to Enter button, which ensures all motion stops before unlocking the door. This safety feature protects users from moving components and allows safe access to the interior. The system allows operators to manually move the XY gantry using the jog controls on the HMI. While the full range of motion is available along both axes, typical part cycling will not always use the full range. The end-of-arm tool uses a vacuum suction cup to safely pick and place lightweight parts. The cart is capable of fully cycling parts between nests. To start a cycle, the green Cycle Start button must be pushed. In order for a cycle to truly start, a part must be in the operator's nest. Each part is identified by its barcode, picked up using the vacuum-based EOET, and placed in the appropriate nest. Some motion can be programmed and controlled through the HMI by operators, or it can be programmed through the PLC in the Siemens TIA portal. As shown here, the system performs a complete pick-and-place cycle and then returns to its home position. The HMI has many different screens for operators to use during the training process. The first screen is the main screen. The main screen provides a live status of each part nest, indicating whether a part is present. It also displays the most recently scanned barcode and the current X and Y servo positions. Operators can toggle between manual and automatic modes and exit the runtime from this screen. A persistent status banner at the top communicates system messages, next steps, and any active faults or alarms. The next screen is the manual screen. This screen allows operators to directly control components while the system is in manual mode. From here, users can cycle the cylinder between home and work positions and control the vacuum system with enable and blow-off functions. This is the I/O navigation menu screen. It serves as a central hub for input-output configuration. Operators can choose between viewing Point I/O or I/O Link screens. The Point I/O screen displays the live status of all discrete Point I/O channels on the cart. Inputs and outputs are grouped by category, including safety signals, digital inputs, and digital outputs. Operators can monitor devices such as light curtains, emergency stops, gate switches, and vacuum controls in real time. The I/O Link screen displays the status of all inputs and outputs communicated through the I/O Link system. The master and slave blocks are shown with live feedback from devices such as sensors, proximity switches, and the valve stack. This gives operators a clear view of the I/O network's health and activity. On the servo navigation menu screen, the operator can access detailed servo controls. From here, operators can choose to view and control the X-axis, Y-axis, or a combined view of both servos. It serves as the main hub for navigating all servo-related functions. The X-axis servo screen provides full control of the X-axis servo. Operators can teach and save specific positions, adjust velocity, and monitor live feedback like position and torque. In manual mode, the servo can be jogged at a defined speed, and status indicators show key conditions like over travel, readiness, and fault states. The Y-axis servo screen mirrors the functionality of the X-axis servo screen, providing full control of the Y-axis servo. The servo combo screen allows the operator to move both servos simultaneously to a selected nest position, streamlining manual navigation. It provides a more efficient alternative to issuing separate move commands from the individual X and Y servo screens. The next screen is the production screen, which provides an overhead visual of the gantry system, allowing operators to track its position relative to the nest layout. It also displays the coordinate system for the X and Y axes, helping users understand motion direction and spatial orientation during operation. The final screen is the fault screen. It logs the history of all system faults and alarms. Each entry includes the time, date, and status of the event, providing operators with a clear overview for troubleshooting and system diagnostics. One of our biggest challenges was bridging the gap between the team's general PLC knowledge and working specifically with Siemens PLCs. Before this project, none of us had programmed with Siemens systems. Through collaboration with engineers at Mission, we were able to learn the platform and successfully implement the required components into our design. This cart gives Mission a powerful new tool for onboarding engineers and growing Siemens expertise in-house. We're proud to have developed a system that will support real-world training and long-term development. Thank you to all who supported us throughout this project, and thank you for watching.